squared 2a times positive 5b is positive 10ab. Negative 4b times 3a is negative 12ab. And negative 4b times 5b is negative 20b squared. Let's look for like terms. These like terms right here in the middle are alike right here. So that's 6a squared minus 2ab minus 20b squared. Bam! Okay. Let's FOIL this. First we will distribute to our, so this, we'll take this x and multiply it times all of these terms right here. X times x squared is x cubed. X times 2x is 2x squared. X times 4 is 4x. Negative 2 times x squared is minus 2x squared. Negative 2 times positive 2x is negative 4x. Negative 2 times 4 is negative 8. Alright, let's look for some like terms. I see a cube term here. Okay, that's the only cube term, so I'll copy that one. Shoot, come on, pen, don't do this. X cubed. I see a 2x squared and a negative 2x squared. Great. I love it when those cancel. And I see a 4x and a negative 4x. Great. An even better cancellation. And we're left with our measly negative 8. So this is just x cubed minus 8. Final answer. Cool. Okay, 15. Same deal. Same deal. X times x squared is x cubed. X times negative 3xy is negative 3x squared y. X times y squared is positive xy squared. Negative y times x squared is negative yx squared. Negative y times negative 3xy is negative 3xy squared. And finally, negative y times y squared is negative y cubed. Okay, let's go back and check out some great opportunities to combine like terms. If you guys see any, let me know, because I sure don't see any. I don't see any. I'm calling it. This is the final answer. It's good protocol to arrange your terms in descending order, but I see that most of these, all of these terms have a degree of 3. So, it doesn't matter. That's good. 16. I don't know if these are going to be on the test or not, but it would be good to know how to do them. First, what we'll do is we will concentrate only on these first. Well, let's concentrate on these last two right here. So let's FOIL these last two terms. So, when we're going to ignore this x minus 3 for now. So x times x is x squared. X times negative 1 is negative x. 2 times x is 2x. And 2 times negative 1, I'll continue to be consistent, draw my arrows. 2 times negative 1 is negative 2. Let's combine the like terms that we see, so that gives us x squared plus x minus 2. Alright, now let's bring down our x to the negative 3 and bring it right here. X minus 3, like that. Now let's FOIL this. Let's take our x and multiply it times all these terms. So x times x squared is x cubed. And let me get another color going here. X times x squared is x cubed. X times x is x squared. X times negative 2 is negative 2x. Now let's look at this term, this negative 3. Negative 3 times x squared is negative 3x squared. Negative 3 times x is negative 3x. And negative 3 times negative 2 is positive 6. I'll combine some like terms. I only see one cube, so I'll recopy the cube down. I see two squares. I see an x squared and a negative 3x squared, so that's negative 2x squared. I see negative 2x minus 3x, so that's minus 5x. and I'll tack on that 6 plus 6. We have a nice, tidy little 4-termed 3-degree polynomial going on. Okay, 17. A problem like 17 will not be on the test because we have not learned how to factor. Let's go to 18. All right, wake up, listen very carefully. I'm going to show you the wrong way to do this. And I'll even write it out here, so in case your speakers go out as I'm demonstrating this, you won't think this is how to go. The wrong way. The wrong way would be to take this 2 and distribute it to both of these terms, thus ending up with x squared plus 9. No, that is not the correct way to do these. The reason that doesn't work is because we are adding these terms. X and 3 are separated by this plus sign. That would be legal if there were no plus sign here and it was just x times 3, or 3x. But it's not. What this problem is really telling us to do is to recopy. Come on. Well, let me ask you a question. What's a squared? Oh, well, that's a times a. Okay, well, all we did, this square just tells us to rewrite this base twice and multiply it by itself. That's exactly what this square is telling us to do right here. So let's rewrite the base being x plus 3. So x plus 3 times x plus 3. Perfect. Great. We expanded that. We took this square for what it was telling us to do and just rewrite the base twice. Now we'll use double distribution. X times x is x squared. This x times that 3 is 3x. This 3 times that x is another 3x. And this 3 times this 3 is a 9. And we have some like terms. X squared plus 6x plus 9. And this is the answer. It's also a special case of polynomial. It's called a perfect square. This is called a perfect square trinomial. And we'll discuss that more in depth. But this is good stuff. This is, back in my day when I took algebra, this is what we did on day 1. So, anyway. Number 19. Oh, good. We're getting a little bit easier here. We're taking this monomial and multiplying it times this binomial. 2xy times x is negative 2x squared y. Negative 2xy times negative 3 is positive 6xy. Final answer. No like terms. That's it. Okay. I'm going to leave this 1/2 alone for the time being, and I'm just going to recopy it right here. So 6x times 2x is 12x squared. This 6x times 4 is 24x. So, yeah, as you can see, this is going like a little bit in reverse, and our 1/2 is still out here. But guess what? Our 1/2 also distributes. So let's take a look at that. Let me switch colors here for contrasting purposes of contrast. 1/2 times 12x squared is 6x squared. 1/2 times 24x is, what's half of 24? 12x. There you have it. Final answer. And it wouldn't be all bad. You can keep that. Yeah, you could keep that 1/2 outside of there, I think, because that's still simplified. But anyway, that's how you would multiply that 1/2, distribute that 1/2 through your 2 terms. All right, let's move along. Move along. I think we. Whoa! Very good. Very good. Let's take a look at that. Dictionary.com. Oh, looks like the internet's down. That's great. Okay. Anyway. Oh yeah, we were gonna look. Oh yeah, we were gonna look up the etymology of polynomial. Okay, it's geometry time. I can't think of anything better than 1, 2, 3, 4, 5 geometry problems. Okay. Let's turn on our pen tool. The perimeter of a square is very easy. In a square, you know that all the sides are of equal length. So we are given that one side of the square is x plus 5. That means all 4 sides of the square are x plus 5. So we know that the perimeter of a square equals 4 times